All right, here we have learning target 9.3, and we're making a big jump in terms of what we can do in trigonometry, because in 9.3 with the law of sines, we are learning some formulas that will apply to not just right triangles, but any triangle. Okay? Now here is our first look at the law of sines. Okay? Based on this diagram. However, on this slide I do want to take a look at a quick little derivation just to give us some sense of where the law of sines come from, and actually its derivation really isn't terribly tough. Now, as far as how to use it, it gives us three options because it works for any pair of angle and its opposite side. We only use two of the three, but set it up with two of the three and solve for what's missing. Okay? Now, really quick here, just a little background as to where the law of sines comes from. We've got this triangle. Let's say it has height h. Okay? And over here, I'm going to write down C, and in particular C sine value if I'm just thinking about that right triangle that's formed by drawing in the height over on the right side. The sine of C is h over a. Slightly rearranging that equation by multiplying both sides by a leads to a sine C equals h. Now with this triangle over here on the left, let's do the same thing with angle A. The sine of angle A is h over C. Multiplying both sides by C, we have C times the sine of A equals h. And I have these two expressions here and here that both equal h. What I can then do is say that C times the sine of A, that must be equal to A times the sine of C. Kind of a random little final step here, but if I divide both sides by the quantity A times C, here the C's cancel, here the A's cancel, and I'm left with sine of A divided by side length A has to be equal to the sine of C divided by side length C. Okay, now that only verifies two of the three, but I think you get the idea at this point. We could certainly have picked B and C and could have pulled it off. Okay, it also works for B. I'm going to skip that part of the derivation, but again, the idea here is to show you that it's not really super crazy to see where the law of sines comes from. It's just based on the sine ratio that we learned in learning target 1 and continued to practice in learning target 2. We take the sine value of a couple angles, work with it a little bit, solve, and there you go. Let's use it. Okay, let's use it. Solve the triangle. All missing sides, all missing angles. Okay, now I've still got all those other tools that I had before. Okay, well, I shouldn't say all of them. Those ones that, SOHCAHTOA, that only works for a right triangle, and I don't believe this one is, but what I'm getting at here is in any triangle, all three sides have to add up to 180 degrees. And that tells me angle C is 105. Okay, we shouldn't forget about that type of stuff. Okay, now I got two side lengths I got to find. And I'm just going to start with C. Okay, C divided by the sine of 105. Now, which one am I going to set it equal to? Remember, the sine, or the law of sines gives me three options. I only need to use two of the three. because I already have a missing component, side length C, I need to pick a ratio in which I know both the angle and the opposite side. It looks like angle B and side B is the best option. C divided by the sine of 105 must be equal to 9 divided by the sine of 30. Okay? Now we have two proportions that are equal to each other, two ratios that are equal to each other, I should say. I can just cross multiply and divide. Take the sine of 105 degrees, multiply that by 9, and then divide that by the sine of 30. Okay, and that would tell you side length C. All right. As far as a number answer there, I'll leave that one up to you. Okay? I think you can try to finish it off from there. Instead, I'll take the time to set up the next one to find A. A divided by the sine of 45. And once again, I need to pick a combination where I know the side and the opposite angle. And if I had already found C, either one would work. I obviously didn't work that one all the way through to get a number answer. But I could certainly just say I'm going to use 9 over sine 30. I could use that again. Okay, and then say that A would be the sine of 45 times 9 divided by the sine of 30. Okay, and again, I'll leave that one up to you to get a number answer to go with that. Let's take a look at finding an angle. This one wants us to find C. Okay, let's start with that. Sine of C over side length C, which is 7. Again, I have to pick a combination here where I know both the side and the angle. It looks like angle B and side B is a good option. This would be sine of 126 degrees over 12. Okay? I could that's the nice thing about the law of sines is it's always set up where I can just cross multiply and divide if that's the way I want to do it. 7 times the sine of 126 degrees over 12. Okay? Now it's important to note here this next step is not going to tell me angle C. Rather, it is going to tell me angle C's sine value. Okay? I would still have to go to my calculator and take the inverse to get an approximation for the actual angle. Okay? 28.2 degrees. Now, one thing we need to consider that we've already talked about a little bit is there may be more than one possibility for an answer because there is more than one angle that has a sine value of 0.472. Okay? Now, to generate that other possible angle measurement, we would take 180 minus 28.2. Okay? That equals 151.8 degrees. Now, we're not saying that that angle is even possible, but it would be 151.8. If we plug that in for angle C, it would work. It would be a solution. Okay? Now, one quick way to check this is to just use the fact that all the angles in this triangle have to add up to 180 degrees. And right off the bat, I see that angle B is 126. Add that to 151.8, and that's already way more than 180. Okay? There are times that this second possible answer will be plausible. In this case, it's not. Okay? The only possible answer that I could have for this missing angle is 28.2 degrees. Okay? Nothing else is going to work. It is important to be conscious of that alternative alternative answer and to see is, you know, I should be thinking after I find my answer, here's this other possibility, could it potentially work? Here's a case where I see that no, 151.8, even though it fits the equation and it's a solution to the law of sines, it doesn't make any sense in that triangle. All right, last little example to work with. This is another one I'll set up for you, but I'll leave it up to you to finish it and get an answer. It says a fire tower, I'm assuming a tower in a forest that's used to spot fires, is at point A, which is 30 kilometers north of Tower B. Okay, that's what that information tells me. Point A is 30 kilometers north of B. A fire at point F is observed by both towers. Let's just say it's over here. And angle FAB, that would be right here, is 54 degrees. And angle ABF is 31 degrees. How far is A from the fire? What is the length of AF? Okay. Again, the nice thing about the law of sines is it's so consistent in terms of how we use it to solve. Okay. To set it up here, I'm looking for side B. I can divide that by the sine of 31. Now, the only side length I know is the distance between A and B, and that's 30. Now, to use that, I have to know angle F, which the problem doesn't give me. Okay? That's okay. 180 degrees is the sum of all three angles. The first one is 54. That's angle A. Angle B, it told me it was 31. Which I can then figure out here that the angle I will use down here would be, I believe, 95 degrees. 180 minus 54 would be 126, minus 31 would be 95. And then, as always, we will cross multiply. It takes 30 times the sine of 31 divided by the sine of 95, and we'd have the distance of Tower A from the fire. Okay? There's a quick look at the law of sines, where it comes from and how it's used. All right? I would make sure you take a little time here to work through those problems, get some actual answers, and if next time we see each other in class, if you want to run those answers by me to verify that you did them right, we can certainly do that.